Hello learner, welcome once again to Manifested Online Classes. My name is James Kenyani. We are going to proceed with our lesson on similarity and enlargement. And in our lesson today, we are going to learn about area scale factor. So the lesson is area scale factor. And as usual, each of these lessons should have an objective. Why learn about that? So this is just to enable the learner to understand what area scale factor is and use it to solve problems concerning area scale factor. So as it goes, it is to enable the learner to understand scale factor and use the knowledge to solve problems. The problems will not only be in mathematics, but sometimes outside there, maybe when you are dividing pieces of land, sharing out areas of land, it will be of importance. So to start with that, we have to look at two triangles that will explain that. So we shall have two triangles. So there is a condition given, triangle, not triangle, sorry. We like mentioning that it is rectangle. So we are looking at two rectangles, P and Q. So the condition is rectangle P is similar to rectangle Q. So we've already mentioned in the earlier lessons about corresponding ratios of corresponding sides being equal. We can see 4 divided by 2 is 2. 6 divided by 3 is 2. That is a clear condition that the rectangles are similar. Let's look at the area of P. Area of P is equal to 3 centimeters times 2 centimeters. That gives us 6 square centimeters. 6 square centimeters. Let's look at area of Q. Area of Q is equal to the 6 centimeters times the 4 centimeters. 6 centimeters times 4 centimeters. Learner, you get what? You get 24 square centimeters. So we have area of Q and area of P. When we are talking about similarity and scale factor, we are either making this small or making it big. When the scale factor is more than 1, it is making it big. When the scale factor is less than 1, it will be smaller than that. So we shall come and say area of Q divided by area of P learner will give us 24 centimeters squared divided by 6 square centimeters. If I work out that, learner, the centimeters cancel. I get 4. So in short, the area scale factor, when we are comparing the smaller triangle and the bigger triangle, is 4. So we come and write area scale factor, Lana, scale factor. You can just write ASF is equal to 4, which is the same as 2 squared. But if you look at that, the linear scale factor is 6 divided by 3, which is 2. 4 divided by 2, which is 2. Let's look at the two triangles. We shall look at again. Again, we can let area of triangle Q, rectangle, area of rectangle P is equal to 3 centimeters times 6 times 2 centimeters, which Lana gives us what? It gives us 6 square centimeters. We want to look at to bring that area scale factor, and we know the relationship between the linear. Area of Q we shall assume now we are multiplying by a certain scale factor K. It will be 3K times 2K, 2K. That gives us what, Lana? I've assumed that now I'm using the linear scale factor. It will give us 6K centimeters squared. 6K centimeters squared. So I can also come and write area scale factor. Area scale factor is equal to, take this 6K squared over 6 centimeters squared. This will cancel with that with that. So it equals to K squared, where K is the linear scale factor. Where K is the linear scale factor. So you should notice that for any, if the linear scale factor is K, the area scale factor is the square of the linear scale factor. It will be K squared. This is true for all similar figures, similar to all similar Lana, note that this will be true for all similar figures. So it's always good to do a recap. What were we coming to? We started with the two rectangles in the name of P and Q. So in short, the area scale factor will be given by the area of these. When you are comparing this to this, the area of this divided by that. So we worked it out using the units. And we get the area scale factor was 4. Now in the second explanation, I assume now I have K. You multiply this side by a linear factor to get that side. So instead of writing that 2, I put there K, just to show the relationship between the linear scale factor and the area scale factor. On working out, I found out that the area scale factor is the K squared, where K is the linear scale factor. Therefore, we conclude if the linear scale factor is K, the area scale factor is K squared. This is true to all similar figures. That is true to all similar figures. So note what happens. Whenever you know the dimensions of these, it is easy to get the area scale factor. But once you know the linear scale factor, you square it, learner. You square it to get the area scale factor. Like if the linear scale factor is 5, the area scale factor will be 5 squared, 25. If the linear scale factor is 10, the area scale factor will be 10 squared, that is 100. If the linear scale factor is 12, the area scale factor will be 12 squared, which is 144. So having gone through all that, there is a short assignment. So there is an assignment from Patel, Mathematics for Schools by Patel Lana. For those who don't know, Mathematics for Kenya Schools by Patel, exercise 7.3, number 3, number 4, number 5, 6, and 7. So it will be good if you attempted those questions before the next lesson. Thank you very much and have a nice time. Bye.